Trig Identities. So this is the last section that we'll be looking at in Trig, and basically we'll be looking at using pages 13, 14 and sometimes even 16 with the sine and the cosine rule to basically show that the left-hand side is equal to the right-hand side. So the way in which we're going to be asked these questions is to prove the following identity. So in other words, show that the left-hand side is equal to the right-hand side. So our first example is that we're going to be asked to show that cos A multiplied by tan A will give us sine A. So in other words, if we were to put into our calculators sine 30 degrees multiplied by tan 30 degrees, that would be the same as getting sine 30 degrees. In other words, we'd end up with a half. So to do that, we're going to take the left-hand side, which is cos A multiplied by tan A, and I want to manipulate this left-hand side so that I end up with sine A. Now, if I look at the top of page 13, we can see that sine can also be written as sine A over cos A. So that means I can say cos A multiplied by, and instead of tan A, we say sine A over cos A, and I say ... tan is equal to sine over cos. So in other words, I'm backing up. Where did I get my answer? And now that's it, we're done, because cos goes into cos once, and 1 times sine A is sine A. And that's equal to the right-hand side. So we say, therefore, the left-hand side equals the right-hand side, and we always have to conclude with the original statement. Hence, cos A multiplied by tan A is equal to sine A, irrespective of what that angle A is. Okay, so the next one we're going to prove is that sine theta over the square root of 1 minus sine squared theta is equal to tan theta. So again, we start with the left-hand side. Generally, the left-hand side is always the more complicated side. So that's why we always take the left. And we write down the left is sine theta over the square root of 1 minus sine squared theta. Now, if I go back to page 13 there in my maths tables, you can see that we have our most commonly used identity, cos squared plus sine squared is equal to 1. So if I say cos squared theta plus sine squared theta is equal to 1, well, what that means is that cos squared theta is equal to 1 minus sine squared theta. So that means that instead of 1 minus sine squared theta on the bottom here, I can say cos squared theta. So I say ... And of course, the square root of cos squared theta is just cos theta. And what do we know about sine over cos? Well, again, go back to the top left-hand side of page 13. Tan is sine over cos. So that means that sine over cos theta is tan theta. That's the right-hand side. And we say again, therefore, left-hand side equals right-hand side. Hence, that means that this original statement, sine theta over the square root of 1 minus sine squared theta is equal to tan theta. And again, obviously, if you were to put in any value for the angle theta there, the left would give you the same answer as the right. So this is third example here. We have 1 plus tan squared theta multiplied by 1 minus sine squared theta is equal to 1. So again, we take left-hand side, which is 1 plus tan squared theta times 1 minus sine squared theta. And I want to show that that's equal to 1. So if I go to page 13 in my tables, I can see that 1 plus tan squared theta is equal to sec squared theta. And I know from the last example that 1 minus sine squared theta was cos squared theta, because cos squared theta plus sine squared theta equals 1 there on the top page of 13. So we say sec squared A equals 1 plus tan squared A, and cos squared A plus sine squared A equals 1. So if cos squared plus sine squared equals 1, that means that cos squared is equal to 1 minus sine squared. And if we look over here on page 13, sec is equal to 1 over cos. So that means that sec squared is 1 over cos squared theta. And then cos goes into cos, so cos squared goes into cos squared, which is equal to 1. And that's equal to the right-hand side. So we say, therefore, left-hand side equals right-hand side, hence 1 plus tan squared theta times 1 minus sine squared theta is equal to 1, which is what we were asked to show. Let's get rid of those dots. Okay, so we'll do one more. So this one is a little bit different because it's b cos a plus c cos b equals a. So for this one, what we're going to do is we're going to use the cosine rule. And the cosine rule is page 16 in your maths tables. Okay, so in other words, a squared is equal to b squared plus c squared minus 2bc cos a. So here what we have is cos c and cos b, right? So if we're taking the left-hand side, we have b cos c plus c cos b. So what I'm going to do is I'm going to write cos c in terms of a squared, b squared, and c squared. So based on my cosine rule here, that can be written in any different format, okay? So if I'm looking at cos c is going to be a squared plus b squared minus c squared all over 2ab. And the same then can be said for cos b. Cos b will equal a squared plus c squared minus b squared all over 2ac. So I'm going to replace this cos c with what I've just written there on the right hand side. So a squared plus b squared minus c squared all over 2ab plus c times, and instead of cos b, a squared plus b squared, a squared plus c squared minus b squared over 2ac. Let's do a line down there. Okay, so what can I cancel with the top and the bottom here? Well, b will go into b once, c will go into c once, and that leaves me then with a squared plus b squared minus c squared all over 2a plus a squared plus c squared minus b squared over 2a. I can see my lowest common denominator there is 2a, so that means I can add these two fractions. So a squared plus b squared minus c squared plus a squared plus c squared minus b squared all over 2a. Now on the top line there I can see a plus b squared and a minus b squared, which is 0, a minus c squared and a plus c squared, which is 0. And then that leaves me with 2a squareds divided by 2a. And of course 2 goes into 2 once, a goes into a squared, a, which is the right hand side. So therefore we say left hand side equals right hand side. Hence that means that b times cos c plus c times cos b is equal to a. Okay, so you're just manipulating any of the identities on page 13, 14 and 16. Now there's one special one that I want to show you, and that's the top of page 13. And that's this one here that we used a second ago. Sec squared a plus tan squared a. Sec squared a equals 1 plus tan squared a. So if I was asked to prove that, prove 1 plus tan squared a is equal to sec squared a, then what we actually do is we start with what comes before it, which is cos squared a plus sine squared a. So that's the first on your proofs list. So that means that can be used to prove anything after it. So if I look here, I want to get a 1 on the right-hand side, okay? I want to get a sec squared, I should say, sorry. and I want to get a 1 here. So to get a 1 in that position, that means I must divide everything by cos squared a. So in other words, if I have cos squared a over cos squared a, sine squared a over cos squared a equals 1 over cos squared a. In other words, I'm doing the same to both sides, so I'm not changing the value of this function, of this identity. So cos goes into cos once. Sine squared over cos squared is the same as saying tan squared. And 1 over cos squared, if we look over here on the left-hand side, well, that's sec squared. And then you're done. So we'd say dot, dot, dot. Sec A equals 1 over cos A. And tan A equals sine A over cos A. All right, so I've given you a handout with loads of different identities to try out there. So you're doing the questions that are marked. Okay, so I'll write them down here just in case you're not sure. So I've done the ones that have EG next to them. So you're going to do 3, you're going to do 6, you're going to do 9, 11, 12, you're going to do 15, 17, 19, 20, 21, 22, 24, and then if you turn over the page, you're going to do 27 and 31. So it seems like a lot, but the more of these identities you do, the better you get at them. So it's all practice, 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 plus it's a double class today. And I'll check in at the end so that if there's any of them that need to be done, I'll do them live.